I am teacher Steph, and today we are starting a new topic in chapter 3, which is mixture, called separating mixtures. So, have you ever wondered how we get salt from seawater or how clean water is made? So, for today, we will learn the different methods used to separate mixtures. And of course, by the end of this lesson, you will be able to explain what a mixture is, describe different methods of separating mixtures, and number 3, choose the correct separation method. Let's begin. So take a look at this photo. What is the use of a tea bag? Think about your answer for a moment. Of course, a tea bag keeps the tea leaves inside while the tea passes into the water. This is an example of separating a mixture. And let's learn more about how mixtures can be separated. So what is a mixture? A mixture is made up of 2 or more substances that are physically mixed together. The substances keep their own properties because no chemical reaction happens. For example, salt mixed with water is a mixture. Examples of mixtures. Here are some examples. You have your sugar solution, your salt water, smoke, marbles in water, but vinegar and baking soda are not mixture. Why? Because they react and form new substances. Always remember this. Physical mixing is mixture, while chemical reaction is a new substance. So why do we need to separate mixtures? The substances in a mixture are not chemically joined. That is why they can be separated. Scientists choose the best method by looking at the properties like solubility, boiling point, and of course particle size. So today we will learn 6 methods of separating mixtures. They are number 1, evaporation, number 2, crystallization, number 3, simple distillation, number 4, paper chromatography, solvent extraction, steam distillation. And now let us begin with the first method. Evaporation is the process where a liquid changes into gas because of heat, of course. And it is used to separate a soluble solid from a liquid. For example, seawater is heated by the sun. The water evaporates and the salt is left behind. Salt dissolves in water to form salt water, right? And when the solution is heated, the water evaporates. The salt does not evaporate and it stays in the container. So this is how evaporation separates salt from water. So we have the simple water still. This picture shows us simple water still, and it is used to get clean water from muddy or dirty water. The sun heats the water and the water evaporates, then cools and becomes clean water again. And of course, the dirt stays behind. The next method is crystallization. So crystallization is used to obtain a pure solid from an impure solid. First, the solid is dissolved in a solvent, then the solution is heated. So this is the process of crystallization. First, when most of the solvent has evaporated, the solution is left to cool. And as it cools, pure crystals begin to form, right? And the impurities stay in the remaining liquid. Finally, the crystals are collected. The next method is simple distillation, and it is used to separate liquids with different boiling points. The mixture is heated. The liquid with the lower boiling point evaporates first. This is the distillation process. Of course, the vapor moves through a condenser. The condenser cools the vapor, and the vapor changes back into a liquid. And this pure liquid is called the distillate. We have fractional distillation. Of course, if a mixture contains more than one liquid, we use fractional distillation. And for example, crude oil is separated into different fuels such as gasoline and diesel. The next method is paper chromatography. It is used to separate different colors in ink or dye. This method is often used in laboratories and forensic science. So this is chromatography process. A small drop of ink is placed on a special paper, and then the paper is placed in a solvent, and the solvent moves up the paper, and different colors move at different speeds. This separates the colors. Scientists used RF value to identify substances. The formula is RF is equal to distance traveled by the component divided by distance traveled by the solvent. The RF value is always between 0 and 1. The next method is solvent extraction. Some substances dissolve in one liquid but not in another. Scientists choose the right solvent to separate the substances. So we have this example of solvent extraction. Of course, in this example, we have here iodine, which dissolves in tetrachloromethane, but salt does not. The two liquids do not mix, and a separating funnel is used to separate them. We have here the last method, which is steam distillation. This is used to separate substances that are damaged by high temperatures, such as essential oils. Steam is used instead of direct heat. The steam carries the essential oil. The vapor is cooled and changes back into liquid. The oil and water separate, and the essential oil can be collected. Today, we learned that mixtures can be separated because their components have different physical properties. We also learned 6 methods of separating mixtures: evaporation, crystallization, simple distillation. We have paper chromatography, solvent extraction, steam distillation. So I hope you have a better understanding of how these methods are used in science and in everyday life. Thank you for watching.